Alright, one-sided and two-sided limits. So we can see that the limit of the function in example 1 is 3, whether x approaches 1 from the left or the right. Alright, so let's go back and look at that. Okay, so you can see as we approach 1 from the left, or from this way, what's our limit? Our limit's going to be, we found out what our limit was 3. And as x approaches 1 from the right, it also is 3. Okay. Now, let's get back to our guided notes. Okay. So in example 1, the limit is 3, whether x approached it from the left or the right. We got that. Now, sometimes the values of a function f can approach different values as x approaches a number from opposite sides. When this happens, the limit of f as x approaches c from the left is the left-hand limit, and as x approaches c from the right, that's going to be the right-hand limit, and then there's the notation for it right here. All right, and we've dealt with this notation early on in the year. All right, so let me write that out because it's a little hard to see. So the limit as x approaches c, and then so c to the negative, that's what it looks like. Right, but that's not how we pronounce it. We pronounce it as the limit as x approaches c from the left. And then here, underneath it, the limit as x approaches c, and then that plus sign there, that means from the right. Okay. Now, what we call these are one-sided limits. Okay. Now, in example 4, we want to find the left hand and the right hand limits. All right, so let me go one step further. Okay, so these are both one-sided limits. That right there would be a left hand limit, and this would be your right hand. Alright, so we want to find the limit as x approaches 2 from the left. That's our left hand limit of f of x. Alright, now we have a piecewise function here. Alright, so we have two different functions. Which one are we going to use? Well, as x approaches 2 from the left, the x values are less than 2. So when x is less than 2, we're going to be using that function. Alright, so we're going to say the limit as x approaches 2 from the left, and f of x will be negative x squared plus 4x minus 1. And now what we can do is just substitute in. So negative 2 squared plus 4 times 2 minus 1. So that's going to give us negative 4 plus 8 minus 1. I don't know if you guys can, you're not going to be able to see this. So that's going to be 3. Okay, so I think it's tough to see down at the bottom right there. So this right here, 2 squared is 4. 4 times negative 1 is negative 4. So we have negative 4 plus 8 That's 4 times 2. So that's 4, and then minus 1, that's going to give us 3. So our left-hand limit is 3. Alright, now our right-hand limit. So the limit as x approaches 2 from the right of f of x. Now, what is our f of x going to be? When x approaches 2 from the right, the x values are bigger than 2. So if the x's are greater than 2, we're going to use 2x minus 3 as our function. And then we can substitute in 2 times 2 minus 3. So that's going to give us 1. Okay. Now we need a new page here. Okay, so what do we have going on? We have the limit as x approaches 2 from the left of f of x. That equaled, what did that equal? That equaled 3. And then the limit as x approached 2 from the right of f of x, that equaled 1. Alright, so our left-hand limit was 3, our right-hand limit was 1. Now, this brings us to a theorem, ladies and gentlemen. The one-sided and two-sided limits theorem. So a function f of x has a limit as x approaches c if and only if the left-hand and right-hand limits existing at c are equal. Alright, so what does that mean? That means that the limit, so you see how we found the limit as x approached 2 from the left and as x approached 2 from the right? Alright, so those were our one-sided. Our two-sided limit is just this. Alright, so a two-sided limit would just be, what is the limit of f of x as x approached just 2? And the answer to this would be that it does not exist. And why does it not exist? Because these numbers aren't the same. Alright? So, in order for a two-sided limit to exist, the right-hand limit and the left-hand limit have to be the same. And one more key point. Because the limit as x approaches 2 of f of x does not exist, it is it's discontinuous at that point. Alright, so we have a point of we would have a point of discontinuity at x equaling 2. So that's example 4.